A RAG answer can sound right while using the wrong context. Ragas helps measure faithfulness and context recall instead of trusting vibes. You'll see how to connect the pieces into a workflow that scores generated answers and exposes missing evidence. I'm Professor Pi, teaching AI foundations with simple Python. Retrieval-Augmented Generation hides two common failure modes. One is invention. The model fabricates facts that only sound believable. The other is missing evidence. The retriever never found the passages needed to justify a claim. To a listener, both failures can sound the same. Ragas gives us separate signals, what the generator actually used and what it missed. That split makes debugging RAG systems far quicker. Intuitively, we want two numbers. One asks whether the generated answer is supported by the contexts we actually gave the model. The other asks whether those contexts cover the claims we would expect, based on a gold reference. Imagine a short user question, two tiny documents, and a single expected answer. If the retriever grabs only one doc, the generator can still produce a fluent reply that only half matches the reference. The two scores tell those stories separately. We will build a tiny end-to-end example that shows this clearly. You will see a minimal retriever, a generated response, and then Ragas metrics that make a missing piece visible. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now we create the tiny case to reason about. This snippet creates a tiny RAG evaluation case with documents, a user question, and a gold answer. Fluent answers hide problems, unless the input pieces are explicit, so the code names docs, question, and gold before any scoring happens. The two short documents make the evidence easy to inspect, and gold captures the answer you expect the system to be able to justify. The visible output confirms the case has a small document set and a non-empty reference answer, which gives later metrics something meaningful to compare against. Next, we need a way to pick which document looks most relevant. This example ranks the tiny document set and saves the retrieved context for the question. Retrieval quality is the first place a RAG system can fail, because a confident generator cannot ground an answer in evidence it never received. The code turns question into query words, scores each document by word overlap, selects top ID, and stores that text in contexts. This simple overlap ranker stands in for the retriever in a real RAG pipeline. The visible output shows which document was selected and why that retrieval decision will shape every later score. With contexts captured, we must package everything so Ragas can score it consistently. This code packages the question, retrieved evidence, generated answer, and reference answer into a Ragas dataset. Ragas expects the evaluation inputs to be named clearly, so ROSE uses user input, retrieved context, response, and reference instead of loose variables. Evaluation dataset .from list turns that plain Python data into the object Ragas can score consistently. That structure matters because faithfulness looks at response against retrieved contexts, while recall compares retrieved contexts against a reference signal. The visible output shows one well-formed Ragas row with the fields needed for the next metrics. Now, we extract a quick numeric signal that shows whether the retriever missed expected pieces. This snippet uses Ragas to make a retrieval miss visible as a numeric context recall score. The sample says the system retrieved context, but the reference context list says two pieces of evidence were expected. Non-LLM context recall checks that gap without asking an LLM judge, and single turn A score returns the score for this one RAG turn. Here, retrieving only one of two expected contexts is enough to show how a plausible answer can still sit on incomplete evidence. The visible output turns that missing context into a testable recall value. Finally, we add a judge-based check that compares support and completeness. This example scores the same RAG turn with Ragas faithfulness and context recall using an OpenAI-backed judge. Grounding and retrieval completeness are related, but they are not the same failure mode, so the code asks for both scores. LLM factory creates the evaluator LLM. Then faithfulness.score checks whether answer is supported by contexts, while context recall.score checks whether contexts cover the claims in gold. In a larger test set, low faithfulness points at unsupported generation, while low recall points at missing evidence. The visible output gives the tiny baseline two separate scores, so failures become easier to diagnose. We built a clear diagnostic loop. Define a question, pick a couple short docs, and state a gold answer. Run a retriever and collect contexts. Convert those items to a Ragas dataset and compute both a non-LLM recall and a judge-based faithfulness. Keeping those signals separate is the key. It tells you whether the model invented facts or whether the retriever simply missed something. When to use this approach? Use it when you need to tell apart hallucination from missing evidence in RAG systems. It is especially useful for datasets with short claims and a small set of supporting passages. One caution: judge-based scores depend on the evaluator LLM and prompts, so treat them as signals, not absolute truth. A strong next step is to tune the retriever. For this toy example, try replacing the overlap ranker with a vector index and test different nprobe values to see how context recall changes on your target dataset. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.